In the final chapter of this anatomy book, we now are going to analyze development as human growth carries on from the moment of conception to the moment, of course, that life ends. So we know that at the moment of conception, the zygote is formed from the union of gametes, the egg and the sperm unite. There's two forms of development or periods of development in human history. So we know that from the moment of conception through the 38 weeks approximately in the mother's womb or in the uterus would be considered to be the prenatal period. Of course, most people refer to this as pregnancy. Then, of course, from the moment of birth through all of the stages of the human life, we consider that to be the postnatal period. So be able to differentiate between the prenatal and the postnatal period. As far as prenatal development, the 38-week time period on average, which is the gestation for the human gamete, you have three different stages. So you have the pre-embryonic period that lasts from the moment of conception 2 weeks after fertilization of the zygote. Here the zygote is multiplying over and over mitotically, and it's producing a multicellular structure that is known as the blastocyst. It is this blastocyst that implants in the wall of the uterus within the stratum functionalis of the endometrial layer. Then the embryonic period extends from week 3 through week 8 of gestation. So this is when the conceptus is continuing to grow. There's folds of tissues that develop, and then finally you have rudimentary organ systems that are now seen in the zygote, and it's called an embryo. So this full development period, when you see rudimentary organ systems, would be the embryonic stage, where the embryo it's now called. The final stage is week 9 through 38 of gestation. So this is when the conceptus that is now called a fetus begins to grow even larger, continues to develop all of the organ systems. They begin to function without any assistance from the mother. Of course, after birth, the fetus is now known as a newborn, and the postnatal period of life now starts and begins. So if you're looking at prenatal development, we know the zygote is the fertilized egg or ovum, goes through mitotic divisions or cleavage. You have the 72-hour period where you have this ball mass or grape-like cluster of cells that are known as the morula. You have the blastocyst. We said that's what implants in the uterine wall. The embryo, once you see all three primary germ layers. And then, of course, we said the organs have matured. It's now the fetus until it's time to be birthed. And then we said it would be the neonate. So make sure you can understand the levels of prenatal development, what each one of those levels are called, and then what's going on at those stages. So the overall developmental stage from the blastocyst that implants to the embryo, that the organ systems are rudimentary and they're beginning to function. And then, of course, the fetus, where they can function without mom's assistance. The postnatal period is very rapid, changes that begin to occur. Roughly, there's 5 different stages that can be brought about. So we mentioned the neonate is from birth up to about 1 month of age, and that is the neonatal period. Infancy, of course, is through those first 2 years of age where it's growing, maturing, psychologically, socially, developmentally. Then childhood is from that time until sexual maturation and when puberty actually begins. At this point, when the hormones begin to be released, adolescence begins and will finish until that individual reaches full physical height and maturity. Then from that time until death, we consider that to be adulthood. So during this time, we undergo this process known as senescence, where you start to have, toward the end of the life cycle, degeneration of the organs, the tissues that make those up. Eventually, stress is on some area of the body, and it leads to death. So even without a specific disease state, there's degeneration of the body, and we call that senescence. So a lot of people say we're born to die. So we come into the world, and you've heard me say this, wearing diapers. We go out wearing diapers. We begin to build and tone up at the beginning, and then all of that, of course, begins to degrade and tear down toward the end. And we said this is referred to as senescence. The pre-embryonic period begins, we said, at fertilization. The egg and the sperm unite, so the secondary oocyte and the primary sperm cell that fertilize the egg form the zygote. We know that the blastocyst is what moves into the uterus. It's what implants in the endometrial wall of the uterus. Prior to that, you had the blastomere, which was a couple of hours where cleavage had happened, and you have multiple cells that are present. So it's that ovulated secondary oocyte that is only viable for about 24 hours after the ovary released it in the process of ovulation. So you only have a 24-hour window around ovulation day, which is day 14 of the cycle. Where does it usually occur? It usually occurs at the distal end or the ampulla portion of the uterine tube or fallopian tube. So a majority of pregnancies begin there. The sperm finds the oocyte or the egg and fertilizes it in the ampulla of the uterine tube. Then pregnancy, of course, is going to frequently occur, more optimal within the reproductive tract of the female within a 3-day window. So 2 days before ovulation and 1 day after. The sperm can remain viable, though, in the female's reproductive tract for up to 5 days once they're introduced. So you have 24 hours that the egg is viable. You have up to 5 days that the sperm are viable, but that day 14, 2 days before, 1 day after, so a 3-day window around the day of ovulation of that female cycle. So what happens during fertilization? Well, there's a whole series of events that happen. The textbook does a really good job with showing you step by step, giving you pictorial drawings of what's going on. So we know that before fertilization can occur, the sperm cell and the oocyte itself, the ova or the ovum, singular, they have to go through certain processes. So the sperm's first process is a term called capacitation. So notice that during this time, you have a full series of reactions that happen within the sperm. The flagellum now allows it to be fully motile on its own as an existing cell. There's modification within the plasma membrane of the sperm so that it can actually fuse with the membranes of the oocyte or the egg. And then we know that the sperm becomes attracted to the egg surface and the egg itself by chemotaxis. So we know that following certain chemicals, it migrates into the cytoplasm of the egg and tries to form and become one with the female's pronucleus. The second thing that has to happen before that sperm can actually get in is a chromosomal reaction. So this is, again, the head of the sperm has the acrosome. You know that the secondary oocyte is there. It has several layers around it. One of the big layers is the granulosa cells called the corona radiata, that the sperm has to penetrate this layer. So there's a combination of the movements of the sperm and the enzyme hyaluronidase, which is the enzyme that's released from the acrosome of the sperm that actually will create a hole in the corona radiata or the granulosa cells. So deep to the oocytes, corona radiata is the zona pellucida. This is where the sperm's binding receptors are. So the sperm cells will bind to these sperm binding receptors within this layer. The calcium ion channels in the sperm's plasma membrane begin to open. This allows an influx or a flow of calcium ions into the cell, and it causes the achromosal reaction. So what happens here is those enzymes are released from the acrosome, including the hyaluronidase, and acrocin. So those two enzymes are released. They catabolically now will digest holes in the zona pellucida. You have numerous sperm cells that are trying to get in. So all of those collectively will release enough of these enzymes to break through both the corona radiata and the zona pellucida. But only one sperm will actually find its way to the nucleus of the egg. So now we said once it gets through that first layer, you have the sperm that bind to the plasma membrane of the oocyte. This releases that cortical reaction that destroys the sperm binding receptor. So one sperm is already trying to get in. The rest of the sperm are now being rejected. One reason is because the membrane has reverted its charge around the egg, and then also this cortical reaction begins to happen where it literally creates a blockage to the other sperm by destroying those receptor sites. So you can notice that in the diagram that these specialized secretory vesicles that are called cortical granules, and they show those there in the membrane, are there. They allow the oocyte to start to release enzymes that will catalyze this whole cascade of reactions that destroy all of those sperm binding receptors in the membrane. So now the sperm entry will trigger release of these enzymes from the cortical granules, and this whole process is known as the cortical reaction. Step 5 is where all of the rest of the sperm cells are still trying to get in, but they are now rejected. On very rare occasions, more than one sperm cell could enter the secondary oocyte, and this, of course, is known as polyspermy. But further development after multiple sperm may get in cannot proceed. The fertilized oocyte will now be triploid, or 3N in number, if it has occurred with polyspermy. So 3 sets of chromosomes is fatal to the developing embryo that would develop later on. So usually there's going to be spontaneous abortion or miscarriage of that fertilized egg. It's been has undergone polyspermy and does not survive. Step 6 through 8 is where the plasma membrane of the sperm and the secondary oocyte begin to interact together. So notice the nucleus of the sperm begins to swell, and now it's known as a male pronucleus. The oocyte now, once the entry of the sperm has come into the ovum or the egg, completes meiosis II, and the ovum begins to swell, and now you have the female's pronucleus. Those two pronuclei begin to come together. They intermix together. That allows the chromosomes to intermix. The female now kills the sperm mitochondria. So if you're analyzing a zygote, it should have the mother's mitochondrial DNA and not the father's, because the father's mitochondrial DNA were killed when the mitochondria were killed. So in this section we explain the difference between prenatal periods and postnatal development. We talked about the 3 exact periods that happen during prenatal development, the 5 stages of postnatal development. We talked about tracing the development from the zygote until the fetus develops. We define senescence as this digression of the tissues and the cells and the organs toward the end of the life cycle. So literally a lot of times pathophysiology books say that this is a time where stress is what kills us. So it's either stress on the organ because of damage to it, or it wears out, or a virus or a bacterial infection has degraded it. But again, you can think of senescence that we're born to die. If we define and describe the process of fertilization, including what happens during capacitation of the sperm, the acrosomal reaction that happens, what are the steps of penetration of the sperm, what occurs during the cortical reaction, and then what is the result of fusion of the 2 pronuclei from both the male and the female. And then we define the optimal time for fertilization to occur, that window, 3-day window, around day 14, which is the day of ovulation.